Hi, my name is Matthew Maloney, and today I am demonstrating how to do big data scripting with a Hive type provider. The environment I am using is Visual Studio, and the language I am using is F#. F# is interesting in that it is both a compiled language and a scripting language. As a compiled language, it can be used to create normal desktop applications for both Windows and Linux, and as a scripting language, it can be used to interactively write and execute code. Most languages used by big data scientists are scripting languages. This is because being able to interact with the data is very important. We are going to be using F# interactively here today. While F# is a scripting language, it is also a strongly typed language. Most scripting languages used by big data scientists such as Pig, Hive, and R are weakly typed languages. Strong typing is important in that it can detect and prevent errors at design time, as well as give additional assistance through the development environment to greatly improve productivity. It is this assistance that I will be demonstrating here today. Let's begin scripting. You can see here on the screen there are two panes. The upper pane is where we write and execute code, and the lower pane is where we can see the results of executing the code. I'm going to begin by writing a simple snippet of code. What I am writing is an expression that creates a list from 0 to 100. I'm going to execute this expression by selecting the text and pressing Alt-Enter. You can see in the interactive pane the results of executing the expression, and as can be expected, it is a printout of the list 0 to 100. Now let's start doing some big data scripting. I'll begin by adding the reference to the library that contains the Hive type provider. This tells the compiler to load the type provider and provides us with the samples.hadoop namespace. This namespace contains the Hive type provider that takes the static type parameters that allow me to specify the Hadoop Hive instance that I'll be working with. In this case, I'm going to be using a local single node Hadoop cluster referenced by the string try_F#. Once I have specified the static type parameter to the type provider, the type provider will then connect to the Hive metastore, download the metadata, and project the metadata into a strongly typed representation that I've given the name Hive data. Once I have the type projection, I need to open up a data context which gives me a reference to an object that I can write code against. Once I have the data context, I can begin to explore the data in Hive on the Hadoop cluster. I do this by examining the properties on this object. I can see here that we have 5 data sets. In normal big data environments, you would expect to see hundreds, if not thousands of data sets in this list. Therefore, it is very convenient to be able to quickly search through the data sets to find the one you want. These 5 datasets are all freely available machine learning datasets taken from the UC Irvine Machine Learning repository. Today we'll be using the abalone dataset. We can see here that we are presented with context-sensitive metadata on the abalone dataset, which tells us useful information about this dataset. We can see that the number of samples collected is 4,177, so it is not a very large dataset. We are told that in the metadata that the traditional way of measuring the age of an abalone is to cut the shell through the cone, stain it, and count the rings through a microscope. We are told that this is a painstaking and laborious task. The aim of this dataset is to find easier to measure factors from which a machine learning model can be created that can approximate the age of the abalone using these factors. We will not be doing machine learning today, but we will be exploring the data. I'm going to start examining the columns in the abalone table. I can see here that we have details such as rings, sex, and weight, and that the description of the column is represented here in a context-sensitive manner. So let's start exploring the weight of the abalone in this data set. I'm going to write a query expression that will allow me to write code that will be familiar to those who know SQL. Also note that there is tab completion as I type. If I were to accidentally misspell a property, the F# compiler will underline the error and present me with a useful error message. If I now try to run the code, the error will be caught, and F# interactive will prevent the execution and again present me with a useful error message. Metadata mistakes such as this are common and costly, and preventing such mistakes is very helpful. I will now fix the mistake and try to run again. This time it was successful. We can see that the average weight for the abalone is 0.828 kilograms. So we have just run our first Hive query. As demonstrated, I was able to write F# code, have the F# code translated to a Hive query, have the Hive query executed against the Hadoop cluster, and have the results returned back to me in F#. This means the F# code I write here has the same performance and scalability properties that Hive has. This Hive backend allows the code to scale to very large data sets. Now let's examine the abalone weights a little closer. To do this, I'm going to copy in some code to plot the histogram for the abalone weights. What I'm doing here is I am bucketing into 0.1 kilogram buckets and counting the number of instances that fit into each bucket. I am then sorting by the weight and then charting the results. We can see in the chart that the weights are somewhat Gaussian, but with a strong skew to the left. I suspect this skew is primarily due to the infants in the dataset. To find out for sure, I would like to remove these infants and to recreate the chart. I will do this by adding a where clause. In the where clause, I filter out the infants by only returning the rows where the abalone sex is not equal to the string I. I can see from the metadata that I denotes infants. I will rerun that query, and we can see that without the infant abalone, the histogram no longer has a strong left skew. So that concludes today's demonstration. If you have any further questions, please don't hesitate to contact me. Thank you.